In this short video, we're going to give an overview of the statistics. Specifically, we're going to talk about the fact that the statistics has two basic issues. One is we have too much information, how do we cope with it? And another, we have too little information, how do we decide? So let's first look at the issue of too much information, how do we cope with it? Well, we have basically three ways for coping with lots of information. One is we can make a picture. Another is we can summarize with a few numbers. For example, the measure of what we call central tendency, what we know as the average or the mean value. And we can also talk about how it disperses about the mean. Now, you could have an exam, for example, where everybody got, let's say, 70, and then the mean would be 70, and there's no dispersion. Everybody had the same score. However, you could typically in an exam would have a mean of 70, and then people would have scores anywhere from 0 to 100. So we need to know how much dispersion there is in the data. The other thing we can do is model a probability model, and then we talk about two different kinds, the discrete probability and the continuous probability. All of these ideas are what are called descriptive statistics in terms of different kinds of evaluations that we do. The other issue we want is what do we do when we have too little information? How do we decide? So now let's look at that issue. So the basic picture is this: deciding when we do not have all the information. Basically, we have a population that has all the information, but we don't have access to it because it is too cumbersome, too difficult, or we pretty just cannot get it. But what we can usually do is get part of the values. So the samples we get will be much smaller than the population, the capital N, and we want to make a decision from the small thing about the whole population. So this is what they call inferential statistics, where we're going to infer from the sample what the population is. Okay, how do we do that? Well, decision from the sample data about the population. What is the population doing? So, for example, if you wanted to know what is all of the students doing at CSUN, and we only have the students in our class. So one we could do is estimate a particular population parameter. For example, we could estimate what is the GPA of all the students at CSUN from the GPA of the students we have in our class. Another thing we can do is hypothesis test. Somebody would say, look, I think the GPA of students at CSUN is 3.0, and you think otherwise. So then you're going to check and see whether that was true. We could talk about correlation regression, where we're saying if I study more, I expect to do better on exams. The question is by how much, and we'll analyze that. Goodness of fit. There's a cute story told about that we expect something to happen, and the question becomes, when we get our data, is it fitting what we expect? So we call that the goodness of fit. And then we talk about other things which we won't have time to go into. But deciding when we have many approaches to do something, somebody comes up with a cancer cure, for example, and there are competing cancer cures. Which one do we select? And deciding when we don't know the nature of things. And when things break down, when we're doing something and things break down, what do we do? What do we do? How do we get around it? So anyway, let's look at the estimation issue as an example. Suppose the president of CSUN wants to know the average GPA of all students at CSUN. Now, you can imagine that's a lot of work to find that. But you could come into our class and see our class has only 50 students, so let's get the GPA of those students. If these students that we have in our class are a reliable sample, that are reliable in the sense they sample all of the population in some way, then we can make the average of these 50 students, find that their GPA is 2.5, and we calculate the deviation about that average. And then from that, we can say that we think that we are 90% confident that the GPA of all students at CSUN will be between these two numbers. And we'll be talking about how exactly to do those calculations. Hypothesis testing, same kind of issue here. Someone makes a claim that the average GPA of CSUN students is 3.0. You think it's less than that. And now you want to decide whether or not to either validate the claim that it's 3.0 or say, no, it's not, it's less than that. So we set up an argument that the average GPA is 2.0, that's the claim, and we're saying that it's not, it's less. And again, we can do that and calculate a probability, and if that probability is low, then we would reject it. So this next chart then summarizes the issue. That is, we can either have a question of too much data, how do we cope with it? Or too little data, how do we decide? If we have too much data, we talk about graphing it. We're talking about different methods of graphing it. We talk about summarizing with one or two numbers, and we talk about different methods of doing that. And by modeling it with different probability distributions, and we'll talk about doing that. Now, given the probability, then we can use that to make decisions of estimation and hypothesis testing, which is the two things we'll be covering in this class. So here is what we expect to do then. We expect to answer these two questions. Too much information, how to cope with it. Too little information, how to decide. Thank you very much.